Good afternoon and welcome to today's HydroCAD webinar. My name is Peter Smart. I'm the developer of HydroCAD, and today we're going to be talking about new features that have been released in our latest HydroCAD-10 release. This is a very exciting release for us because HydroCAD-10 actually marks our 25th anniversary. The first release of HydroCAD was in 1986 with a number of local engineering firms, and since then we've spread nationwide, and in fact worldwide. We've got something in the vicinity of 30,000 users overall of our software. So it's very exciting for us to have version 10 out. It has a lot of great new things in it. It really is one of the biggest releases we've had to date. And our goal today is to give you an overview of the new features that we've added in version 10. There won't be great detail on any of these because there are just so many to cover. The goal here is just to give you an idea of what you have in your hands if you've already got HydroCAD-10, just so you'll know what capabilities are there when you need them. And of course, if you're considering an update, then this will give you a preview of some of the benefits of updating. You will, of course, find complete details on the new version 10 on our website. This page is a very rough overview of some of the big items, and we'll be going through those in a little bit more detail today. There are 3 additional webinars that are scheduled over the coming weeks at 2-week intervals, and they will discuss each of these topics in greater detail. So we do have sessions specifically which will cover outlet devices, the new CAD data import capabilities, and also new rainfall options. And you'll find those sign-up links on our website. If you go to HydroCAD.net, click on support and then training, you'll find the webinar list right there. So I would urge you to go to that and sign up for those additional sessions if you want more detail than we're going to have a chance to cover today. Okay. So during today's session, there are roughly 5 categories that I want to cover. The first is just some miscellaneous features. It's sort of a hodgepodge of things that you should know about, but they don't really fit together in a nice clean group. Then we're going to talk about the bigger categories of new outlet devices that have been added to the software, enhancements to underground stormwater chambers, both chamber libraries and new capabilities in the Chamber Wizard. Then we have new capabilities for managing rainfall data, rainfall distributions, downloading NOAA and NRCC data, and generating synthetic rainfall distributions from that data. And then finally, we have a discussion of new data import and export capabilities, which will just touch on the AutoCAD import capabilities, although to see that in action, you will need to sign up for a future session. That one will take a little bit more time, so we're devoting a full session to that topic. So that's the rough outline of what we're going to be looking at today. So let me start by looking at some of the miscellaneous items, and the first of those is something that's hidden on the serial number screen. If you launch HydroCAD and select Setting Serial Number, or if you're just installing HydroCAD for the first time, the serial number form opens, as I'm sure you've all seen. And what I wanted to point out is a new option here to log HydroCAD usage to a file. This has been requested mostly by IT folks who want some better tracking of software utilization, particularly where there are shared licenses and multiple users. And if you have that box checked, then each time HydroCAD is started, it will write an entry to a log file. And the log file simply indicates who was using the software when they started it, when they stopped. And that file simply gets written to the same folder where your license information is stored. And we can also change the extension on that log file, and you could load it into a spreadsheet. So it just provides a simple analysis that admin folks can use to keep track of HydroCAD operation on your system. So just to point out that is available to you. The next thing I want to point out is an installation change, which some of you may notice, others won't. Previously, the HydroCAD sample projects and the default project folder was inside the HydroCAD program folder. So if you went to see program files, HydroCAD projects is where we had things stored. To be more compatible with secure Windows installations, we've now moved the project folder so that instead, if you go to My Computer, and you will find Here we go. If you go to My Computer and then to Share Documents, and it may be a little bit different than naming on different versions of Windows, but within Share Documents, you'll then find a folder for HydroCAD, and within that, you'll find a folder for Projects, and that is basically the same content that used to be in the Program Files HydroCAD Projects folder before. So we've moved it to this location. This allows the Program Files folder to be fully secured. It can now be read-only, as some folks prefer for security reasons. So just to note that change has been made. Now that only affects the default location for project files. You can still have your files stored anywhere you choose. So if you've had projects stored in other locations, they're completely unaffected by this change. This is just a matter of where we're putting the sample projects that are pre-installed with HydroCAD. So now you can just go to Share Documents in order to go back to that folder. You don't have to drill back down into your C drive. Similarly, we've moved the license information to an applications data folder so that also no longer resides in the executable folder for security reasons. So just a couple of things that may be of interest to some of the IT folks who are managing these HydroCAD installations. Okay, next let's have a look at a couple of things within HydroCAD itself. If we come into the Mountain View housing complex project, which is pre-installed with HydroCAD, and there's a new report that's been added. If you come up to your project report button on the top of the toolbar, then several tabs you'll recognize, but there is a ground cover report which is brand new in version 10. It's pretty straightforward to use. I just want to make sure everyone's aware that it's there. And it gives you a new breakdown which shows you the amount of area that is present within each hydrologic soil group and each specific ground cover. So it's a different breakdown, a little more detailed breakdown. And you can see over on the far right which subcatchments actually contain that particular soil group. So it's a handy analysis. Can be particularly useful when you're importing data, such as in the AutoCAD import scenario, because it gives you another way to cross-check the information that's coming in from that environment. And of course, you still have the previous listings, the previous reports. They're still there, broke down by soil group, and then areas, which is a breakdown by ground cover and curve number. So I'll leave you to explore that. Another significant feature of this report that is not immediately apparent, previously the project report windows were modal, meaning that when you had the project report window open, you could not do anything else in HydroCAD, and we've changed that in this release. So I can actually now come back and I can activate the main window. In fact, I can come in and I can make changes to any of the elements of that project. So exactly as you would normally have a node report open before and be able to edit, make changes, and see the results, you can now do that with the project report windows. Those can stay open. There is also a capability for all report windows. If you go to Settings, General, there's an option here to allow multiple report windows per node. Normally, HydroCAD just keeps a single window open per node, and if you double-click a node to open a report window, it gets the existing one. If you prefer, you can check this option in order to have multiple windows open for an individual node. It's a little more complex to manage, which is why that option is unchecked by default, but it's just something else that's there that you might want to take advantage of. Then the next item and the last item in our miscellaneous category is a new text image node, which has been added in version 10. This is in response to requests to add additional annotations to the routing diagram. And what you can do with that is you can just drag that node into the diagram as you would any other node. And we can double-click that to edit. And we can use this to label the routing diagram with any text we like. That's the simplest use for it. So we could do something like that. We could put text on our diagram. And then we can drag that around, of course. The little brackets are just to show you the drag area. They do not appear when you print or export the image. And if we edit this again, we also have the option to put an image in here, so we can remove the text. We come to the Image tab, and on the Image tab we can pick pretty much any graphic file format or even document format. In version 10, in addition to supporting the native bitmap and JPEG images, we can also support most any file for which you have software installed on your computer using object linking and embedding. So for example, we could select here a CSV file, which would normally open in a spreadsheet, and here we have a preview of that CSV file, a table that's being rendered actually by Excel in the background here. And if we click OK, then we have that table actually present within our routing diagram. And we can change the size of that. This image width lets us specify the relative size of that image on the diagram. So this gives you capability to put additional images, tables, reports embedded within the routing diagram. This will recognize PDF files, Word documents, basically anything that you have the applicable software for on your computer. So it's a very handy little capability. Okay, that basically wraps up the miscellaneous items that I wanted to talk about. Next, let's just close out this project. And I want to have a look at the general category of new outlet devices. And there are a lot of new outlets that have been added in this release. And there is a sample project that's pre-installed on your HydroCAD system, which is just called Outlet Examples, I believe. And that's a general overview of different outlets that are available. I'd certainly urge you to take a little bit of time and look at that. But what I have here is a separate project I've set up called New Outlets, just to highlight some of the new features that we've added in version 10. All of these you'd find when you edit a pond and go to the Outlets tab, and if you double-click a blank line, you go to the Outlet Selection menu. And the new outlet devices are all visible on that list. Basically, the new devices we've added include a tube, siphon, and float valve, which are categorized together. We also have an asymmetrical weir, which is a variation of the custom weir and orifice, but custom weir and orifice only allowed for symmetrical weirs about a vertical center line. So asymmetrical weir lets you handle other more general scenarios. We've also added a dam breach outlet, which is used for modeling a progressive dam breach. In previous releases of the software, any dam breach had to exist at the beginning of the routing calculation. The breach could not actually change size or shape as over time. The dam breach outlet allows for those kinds of progressive breaches. We also have some other enhancements to outlet devices. Actually, there's another new one, which is a constant flow outlet or skimmer, and this provides a very simple means of putting in a constant flow outlet or a floating skimmer, which is a common situation which actually in effect produces a constant discharge. So those are some of the outlet devices, and let's just have a look at a few of those in this example. The first of these is a tube outlet. Now a tube is similar to a culvert. However, let's come in and edit this one that's already been set up. A tube is assumed to always be flowing full along its length. Whereas with a culvert, we're looking at variable depth and partially submerged inlets and other complexities. A tube is a simplified case where it's either flowing or it's not. When there's flow in the tube, we're looking at frictional losses within the tube as well as the orifice losses at the inlet. And those parameters are described here on the screen. The orifice coefficient can be specified, the length of the tube, and then the Hazen-Williams coefficient, which determines the frictional losses along the tube. As with a culvert, there is an inlet elevation and an outlet elevation, and then we have a tube diameter, which is specified. If we had several identical tubes side by side, then we could use the discharge multiplier to handle those. So in this initial case where we've selected regular tube, we're describing a situation where the inlet of the tube, or where the tube slopes consistently downward. We're not looking at a siphon scenario, which is the second case. So with a regular tube, flow will initiate once the water surface elevation in the pond rises to the inlet elevation, and then it will flow dropping down to this outlet elevation with the flow determined by the roughness coefficient and the orifice coefficient at the inlet. If we have a tube length of 0, which is an option here, then in fact, or blank, then you notice it grays out the Hazen-Williams coefficient, and we're just looking at orifice flow through this orifice at 12 inches. So it's a simplified scenario. So this is the behavior we might get. If we go to the stage discharge curve, we have a tube, and we have no flow until we get up to the inlet of the tube. Then we get increasing flow with elevation, and I believe here we may have it's free discharge. Then we get increasing flow as we submerge the tube, I believe is what's happening. This is as the inlet submerges over the next 6 inches. So we do have weir flow essentially happening at the inlet, and then we have full tube flow that's occurring once the inlet has been fully submerged. So that's a situation that you could use if you, again, have a pipe that's generally flowing full. Now, another variation on this is you can actually set up a tube to operate as a siphon. This is the second option on this page. And what's distinct about siphon is that the flow does not initiate to some point that's generally above the inlet elevation for the tube. So when the water rises to this specified level, the starting elevation, that's when flow will actually initiate. So we're looking at a self-priming siphon here, perhaps a vented siphon or other situation that will allow the siphon flow to initiate at that elevation. Once the flow is initiated, then the water level in the pond could either rise or drop. If it drops, then the siphon will continue to flow until we hit this break elevation. And this would typically be the inlet elevation for the tube, although not necessarily. When the water falls to that point, then air is introduced into the system, the siphon breaks, and the flow ceases. So we have the start-stop behavior of the siphon, which is used in conjunction with the tube flow calculation. So very much the same as the regular tube, except for the start-stop behavior. And one of the interesting things about this, if we come back now and open up the report window for this node, we can actually see the siphon cycling here. What we have here is a constant inflow coming into this pond, and if I right-click and go to Report Items and turn on the elevation curve, this shows the water surface elevation increasing linearly in the pond, and then when we hit 25 feet, which was the initiation elevation that we've specified, the blue curve shows the siphon flow beginning, and then we start to draw down the level in the pond through the siphon until we hit the turnoff point, the break elevation of 20 feet, and at 20 feet the siphon flow ceases, and then the pond starts filling again until we hit this initiation point, and so you can see that cycle that occurs. If we go to the stage discharge curve, you can see the siphon behavior, and in version 10 these curves can now show the hysteresis. A pump displays a similar behavior in that it turns on at a certain elevation and then turns off at some lower elevation once the level has dropped, and that's the same behavior we see here in the stage discharge curve for siphon. So you get some very interesting behavior with siphons, and this is a new capability to be able to model this kind of cycling in particular. Related to this, there are some devices that use float-activated valves. There's a commercial product, which is a storm filter by Contec, which uses a valve that is designed to maintain full flow through a filter cartridge. And that's an example of another kind of device that could be modeled using this outlet category. And basically what we're doing here, oops, wrong line, is that we're using this third option, which is a float valve. And what happens here is that we have the elevation at which flow initiates, then when flow ceases, and the discharge elevation, similar to the siphon. But we have an additional option here, which is trickle flow. Basically, what we're dealing with here is an imperfect float valve, where when the valve is closed, there is still some flow through the device. So this allows us to use a single screen to describe the on-off behavior of the valve, combined with an equivalent orifice diameter for the trickle flow that will occur when that valve is closed. And this screen makes it particularly easy to model some specialized proprietary devices like the storm filter, which is deliberately designed to have that trickle flow that operates when the valve is closed, basically to draw down the filter chamber. So that's one more option that's available within this general category of the tube, siphon, float valve outlet. They're the same option on the outlet selection screen, although they give you quite a range of different capabilities. The next outlet I want to look at is the asymmetrical weir. And an asymmetrical weir allows you to, I'm on the storage tab, excuse me, here we go, asymmetrical weir, allows you to literally draw the cross-section across your crest. The custom weir option in previous releases required that this be symmetrical, so that if we were to draw a vertical line previously through this cross-section, the left-hand side had to be completely symmetrical to the right. Essentially, all we could do was describe the width across here. Now, with this screen, we're able to describe the height at different offsets. So we start here at the left side, which would be an arbitrary offset of 100 feet in this case, and a height of 6 feet, so that's this point. Then we come over to 105, and we do a height of 0, so that would be this point down the bottom. And then we progress across, and we simply define the offset and the height to each of these points that makes up the cross-section across our crest. And then the software breaks this down into a number of trapezoidal and rectangular weirs in order to calculate the composite flow through the entire system. As usual, if you go to the help system, you'll get a complete discussion of how to set this up and exactly how the calculation is done. You'll find that all of that is in here. And this shows you the kind of breakdown that's being done in parsing that profile that you've defined into a number of triangular and rectangular sections in order to apply the weir equation. So this allows things like perhaps a roadway overflow where the overflow may not be uniform. You might have a 5% road slope in one direction and a 10% in the other. So now you could model that kind of asymmetrical situation. And the routing through this is very much like other weirs. Stage discharge curve is produced just as you'd expect. The difference is just that we have this capability to describe a different kind of crest profile. The next item here on new outlet devices is a dam breach. Dam breaches are new in this version, and what's different about them, what has been challenging, is that they allow that the breach will actually change over time. In previous releases, you could take the breached condition and model that as a custom weir or a trapezoidal weir or whatever shape might approximate it, but you couldn't actually have that cross-section change as time progressed during your routing. With this new dam breach outlet, it does actually progress over time. If we click the Help button, this will give you a lot more information, and there's a sketch here in the corner that gives you the basic idea that what we're doing is we're starting usually up here at the top of our spillway, and at a certain point in the routing we're initiating a breach. The breach has a certain specified width, and then it progresses downward through the dam wall to a final height, which we've also specified, and this development happens over a certain period of time. The sides of this breach can also be trapezoidal, so it could be a simple rectangular shape that's progressing, so we could start with this and progress down to this, or we could specify that it's a trapezoidal shape that's progressing. In all cases, what progresses here is of the depth or the height of that breach. Whatever the width we specify stays constant, any side slope we specify stays constant. And these parameters are all explained here on the help screen. Coming back to the inlets, to the actual entry screen, you can see how everything is set up. The top elevation is where the breach is going to begin. So this is essentially the top of the spillway. The bottom elevation is the lowest point that it will progress to, and this breach height is the difference in those. It's 5 feet, so we have a total breach height of 5 feet. Then we have a bottom width, the width of this trapezoidal section, a notch angle, if we would like this to be trapezoidal, and then a weir coefficient. And then finally, and perhaps most significantly, over here we specify when that breach will actually begin. In this situation, we've indicated that when the pond hits a specific water level, the breach will initiate. We also have an option to specify a starting time as an alternative. So if you want your breach to start exactly at 14 hours, then you can specify that. And then finally, we can specify the time it takes the breach to fully develop. So regardless of when it initiates, in this case, it will take 10 hours for it to develop to this full breach height that we've specified over here. So if we come back and look at the actual model for this case, double-click our pond, we can see very different kinds of behavior with a breach. What we've done in this scenario is we're running a constant flow. This 4 CFS is running into the pond. So once again, let me right-click and turn on our elevation curve. And we can see we have this linear increase in elevation as we're filling our pond. And then when we get up here to our breach elevation, then we start to get, and again, let me just review, our breach elevation here is we're starting the breach at 108. So what's happening here, it takes a minute to understand. You'll notice the pond is actually peaking at 108.7. The breach has initiated, if we look at our message screen, you can see here the breach has initiated at the 108 feet we started, which occurred at 5.56 hours. But at that point, the breach is quite small, so the pond is continuing to fill. The pond fills for another 0.7 feet to hit its maximum, and then the level starts to drop. And this is the rather interesting hydrograph that we get as a result of that breach. So you can model breaches of a wide range of different types with this. It can take a little bit of time to understand the results because it's not an intuitive behavior when the breach is actually changing over time. And of course you can combine these breaches with any other kind of outlet devices. So you can have a normal spillway, a culvert outlet, whatever else you might have on your pond. Again, more on this on future sessions. We can only touch on these in today's 1 hour with all of these topics. Then the other things I wanted to touch on for outlet devices, for all of the places that you have ponds within HydroCAD, this would be reaches, pipe reaches, where you have culvert outlets within HydroCAD. Previously, if you were using an ellipse or an arch pipe, you would have to look up and provide the dimensions directly for those devices. So you would have to provide a top radius, a bottom radius, and then the software would do the math and fill in the corner radius. Now we've added a lookup table within the software, so you can just come directly to this table, and we could specify a corrugated metal pipe, arch pipe with half-inch corrugations, and we could pick the nominal pipe size that we want to use, and it would provide the exact top and bottom radius. So it just saves you a trip to the reference books, and it also has dimensions for reinforced concrete pipe. The round sizes are fairly obvious, but again, it's got these in a table for you. But there's also the elliptical sizes of concrete pipe, which are unique. So all of those are available right here in the lookup table. So pretty straightforward and easy to use. So that's the review of new outlet devices. What I want to do next is I want to come along and look briefly at underground storage chambers. And There's a chamber example project that's pre-installed with HydroCAD. I'd certainly urge you to pull that out and look at it if you haven't. What's changed in this release is we've added quite a number of new chamber definitions. If you come to View Library here on the right and look at Chamber, then this will open up the Chamber library, which lets you browse through the whole collection. And we've added things such as the latest StormTech chambers, the 3500 and the 4500 have been added here. And there are quite a number of other new chambers you'll find in the list. This is up to date now. But some of the more interesting stuff comes up when you go into the chamber wizard. And when you come into the wizard, and if you haven't used the wizard, this will automatically lay out a chamber system and embed it in the appropriate amount of stone. The bedding, the stone at the sides, the cover, and the ends can all be done automatically by applying the manufacturer's default settings, or you can adjust those based on your own engineering judgment. What I want to show you here, though, is some of the new features. For example, the StormTech chamber I mentioned. If we were to use a StormTech chamber, because it has an end cap, which has quite a significant volume, we now have specific modeling for those end caps. So they actually show up right here in the chamber wizard, allowing for the appropriate amount of storage in the cap plus the space that the additional stone that's needed in order to properly cover that end cap. We also have certain chambers that have custom row length adjustments. For example, a Cultec V8 HD, I believe, is a little bit different than other chambers in that they use a special chamber at the beginning and the end of the row. And as a result, the overall length of that row has to be adjusted, actually reduced by nearly 6 feet. So there is now an automatic row length adjustment which is applied. And that's subtracted in the case of the Cultec V8. For most chambers, you'll notice that that value is actually added back in, because what happens is that each overlap in the chamber you lose, let's say, a foot in this case, but the last chamber in the row, that extra foot is available. So there's an overall row adjustment of 1 foot that's added in. So those row adjustments have been implemented to give you more precise layout calculations when using the wizard. The other big change in the wizard is that it will now do automatic headers for pipe systems. So if we're designing a system with corrugated metal pipe or any of the other pipe options, there is a new option here for headers. So let me just reduce this a little, make it easier to see. So we can increase the number of headers, and we can put one header in. So now we've got a header here down at this end of the system. The header is assumed to be the same type of pipe that the field is made of, and it allows the appropriate space in the stone and does the storage calculation for that header automatically. And if we set it to 2 headers, then we get a header on both ends of the system. So very simple to use, but it saves you an enormous amount of time in laying out these pipe systems. Okay. All right, the next category here is rainfall calculations and rainfall data. This topic can get pretty involved. The amount, the degree to which you'll need to get into this is really going to be determined by your local ordinances and what they're asking you to do as far as rainfall. For most of the projects that you're doing in most of the country, I know that's a broad generalization, but in the majority of cases, people are continuing to use the standard SCS or NRCS Type 1, 1A, 2, and 3 distributions. But in other cases, we're seeing growing use of local rainfall data, including the generation of synthetic mass curves for a specific location. So we now have those capabilities and others that have been incorporated into HydroCAD. The way you get into that, starting from the beginning, if we go to the calculation settings screen and go to the rainfall tab, this is where we would normally select and still do select our storm distribution and other related parameters. This screen has been revised with some new features added in HydroCAD-10. One of the things you'll notice is that there is a new box for storm curve. What this allows us to do is that the software now supports rainfall definition files which may contain more than a single curve. So for example, I have a file that's already been prepared here for Hartford, Connecticut. And when I pick that file, this box up top now lets us select the specific storm curve. In this case, the first of these is for a 1-year storm. And when the software sees that we've selected a multi-curve file, it gives us this option to automatically define the rainfall events in this project. There's 2 tiers here, which takes a little bit of getting used to. But the file can have multiple curves in it, and then within each project we can also have multiple event definitions. Those 2 may correspond one-to-one, or there could be slight differences between them, depending on what you actually are, what your objectives of your model are. So this prompt is asking us whether we want to replace all the events in the current project with the ones out of this file. We can say yes. And now this has automatically defined all 9 rainfall events for this location. So if we come down here to our event selection box, as we make a change in this box, you'll notice that the storm curve circled in green up above will change to match. So these are our project events down the bottom, and as we change those project events, they have now been set to select the appropriate curve from this file and also to apply a specific rainfall depth. So that's one of the ways that new events can be defined. And if you click the Import Events box, there are new options here as well. What we've just done is we've actually defined the events from a multi-event storm. We can also import event data from a TR20 file, either a DOS or a TR20 file, so a DOS or Windows TR20 file. So if someone's already done a TR20 analysis and you have that file, then you could import those rainfall definitions directly from that file into HydroCAD. We also have a capability to define events from an IDF file. So this is an interesting one. Your IDF file tells you rainfall depth for any duration, such as 24 hours. So we could pick an IDF file, and we could come in here and grab a specific file and click OK, and that will define the rainfall events. So we could use this actually with a type 2 storm. That would be an interesting scenario. So we might come back here and pick a type 2 24-hour, but we might want to define the event depths for each of the events, using that Hartford, Connecticut IDF file. So now we've defined all of those different rainfall events, and as we change the event, in the drop-down list, you will notice that the rainfall depth will change over in the box here. So we can change from a 1 year to a 10, or a 10 to a 100, 200. So there's several ways you can define your depths. We also have a built-in lookup table, which was available in earlier versions. This lets you select the particular state and county, and we have made some updates to this table to put some of the new local rainfall information in. This will never be perfect because localities are continuously changing the rainfall data that they want you to use with your projects. So you always need to be reviewing your regulations and aware of what the local agencies are requiring, and you can always define those events right here. So you can, if your 25-year depth needs to be 6.1 inches rather than 6.05, then just go ahead and change it. That's always going to be something that you need to look at and make sure those are correct. But there's a whole bunch of new options here for managing rainfall. Now there's another button that's been added up the top here. View Storm button has been there for a while, and that allows you to view the particular storm you're looking at. But there's also a button labeled More Storms, which you'll see in a couple of different places. It appears here. Also, when I click the View Storms button, there's a More Storms button that appears over here. And this gives you access to a new form which gives you several different ways that you can get additional rainfall information. There are 3 tabs up top. The first of these, with a download button, simply takes you to the rainfall library on our website, and this gives you a full list of rainfall definitions, and you can use this to download any additional standard rainfall tables which may have been defined either since your release or specialized distributions that we've decided not to put in the standard release of the software. So all of that's available to you within the software. You don't need to know what the web address is. The next tab here is local rainfall data. And when we click download here, this takes you to a rain page that's got details on using precipitation frequency data with HydroCAD. Essentially, this allows you to grab data from the NOAA website or the new NRCC website, which are basically IDF curves, and download that IDF data for any specific project location that you want to work on. Those file formats are now recognized by HydroCAD as a native IDF file. So we can save those and open them up in HydroCAD and view them and see all those IDF curves. The other capability that's available in HydroCAD-10 is that we can also take an IDF curve and we can convert it to a synthetic mass curve. So we might come back, using our Hartford, Connecticut example, we have an IDF file for that location, and we could pick the IDF file, and it looks like this. Those are the individual event curves within the IDF, and we can click Create Mass Curves, and it's asking me whether I want to overwrite the previous curves. And what this does is it's generating a synthetic mass curve for each of those events based on the individual IDF data for that specific location. So this creates a bunch of curves which are shown here. So we now actually have the 1 through 500 year mass curves. These are shown here in dimensionless form. And you'll notice the curves are all relatively similar. If we switch to the intensity view, now you'll start to see different intensities that are apparent for relative intensity for each of these events. The actual intensity for each storm is obtained by multiplying this relative value by the overall depth. So if it's 5 inches in a 100-year storm, then you would take the relative depth here of 1.2, multiply it by 5 inches. It would tell you that 6 inches per hour is the actual peak depth for that event. So this lets you compare the different events. It's interesting to notice in Hartford, which I think is near the boundary between the Type 2 and Type 3, that these relative intensities for the different events vary from 0.9 up to about 1.4. Let's take a few of these curves out of here just to make this easier to read. Okay, there we can see the 0.9 and the 1.4. Now, if we lay on top of that a standard SCS Type 2 distribution, we can see it's got a peak, relative peak of nearly the 1.4. So there's not a lot of difference for the 1-year event, but for the 500-year event, it's quite different. On the other hand, if we grab a Type 3 24-hour, its peak is actually down about 0.8. So what this is showing us is that for Hartford, we tend to be a Type 2 distribution for the shorter events and a Type 3 distribution for the longer return periods. Some locations you'll see that this variation between the standard curves. In other cases, you may see that the standard Type 2, Type 3 curves are a pretty good match to the local rainfall data. It's hard to generalize, but if you do look at the rainfall maps and look at the boundaries between the Type 2 and 3 distributions, the closer you get to those boundaries, the more likely it is that using local rainfall data will have differences from using the Type 2 or the Type 3 storms. If you're deep in the Type 2 or Type 3 areas, then as a generalization, you'll see less difference in those relative peak factors. Again, we'll be talking about rainfall data in a whole separate session coming up. So if this is something that you're starting to need to do for new regulations, then we will have more information coming. Another thing that's available to you in the general rainfall and runoff category, if still on the calculation settings screen, if we come over to the unit hydrograph tab, most of your projects have been done with the standard SCS unit hydrograph, which has a peak factor of 484. There are also other unit hydrographs that are pre-installed with HydroCAD, such as the Delmarva unit hydrograph, which has a peak factor of 284. But in the HydroCAD-10 release, we've also added a bunch of gamma distributions. These gamma distributions are another way of generating a unit hydrograph distribution, but with a different peak factor. And if we click View Unit Hydrograph, here's the full library of pre-installed unit hydrographs. So the standard SCS unit hydrograph looks like this, but if we had very flat terrain where we wanted a lower unit hydrograph peak factor, then we could use perhaps 300, 350, 400, or very steep terrain, we could go with a higher 500, 6, etc. So we've expanded the library, and you'll find these distributions are tables that come from the National Engineering Handbook Hydrology, Part 630. So if you go and look at that in the appropriate sections, it gives you a discussion of exactly how these are derived. But just so you know that they're available to you, if you're running into requests for different peak factors, you now could use a different gamma distribution, and that could avoid the need to have to manually generate a new unit hydrograph by hand for special application. Okay, next and last on our list is a quick look at the data import and export capabilities which have been added in HydroCAD-10. This is, again, a pretty broad area. There's a lot of new features that have been added here that all come together. The data import, the easiest way to start looking at this is probably to look at a basic example for tabular data import and export. So an easy way to do this, let's just grab our Mountain View housing project example, which we already have open here. And if we come to the project menu, you'll notice that the categories for import and export have been expanded significantly. And that's where you're going to find a lot of this stuff. So let's start by coming to project export and coming down to subcatchments. Now when we click subcatchments here, what we're going to do with this one click is export all of our ground cover and curve number information to a file, and also export all of our time of concentration information, all of the flow segments that are used to calculate the TC. And that's why this message is saying that it's going to export to default files, because it's going to create these two files automatically. When we click OK, it automatically exports this information. It's a silent export, but what's happened is that back in our projects folder, if I can get back there, so whatever folder the project was in, it's now created two additional files. So this is the project that we actually have open, the Mountain View Housing Complex. And the export process has generated a file here containing flow segments, and then a second file containing subareas. And if we click one of those files to open it, because it's got a CSV extension, comma-separated values, it will automatically open in our default spreadsheet program. So in this instance here in Microsoft Excel, we can see the contents of that file. So for each subcatchment, which is listed in this first column, there's one line for each flow segment. And, excuse me, we're looking at ground covers, not flow segments. So for each subcatchment, there's a line for each separate ground cover. And so here we have our open space in good condition, and this progresses down through the table, showing us the particular ground cover that we're using and the corresponding curve number, and then the area. So we could use this for reporting purposes, or we could actually make changes in this table. People have on occasion wanted a tabular editing capability for a project. Well, what you can do is you can actually come in here, you could make a change to any of these values, such as changing that to 10 acres, save this back to a CSV file, and then you can reload that back into the same project. Similarly, you could use the file for flow segments, and here for each of the subcatchments we have a separate line for each of the flow segments that's being used to calculate the TC. So we have 3 segments, 1, 2, 3, and then we have a lot of different columns here as necessary to define all of the parameters for the different TC procedure. This column here is the specific type of flow: sheet flow, shallow concentrated, channel flow, lag method, etc. And then the appropriate parameters appear in each of the columns. So we could do the same thing here. We could actually come in and we could make changes to any of the values in this particular table, and then we could re-import it back into the project. So this basic tabular import and export capability opens up a lot of doors. If you have other software where you have information being pulled out of a database that you would like to get into HydroCAD, then you could export the information into this kind of file format. And then back in our HydroCAD project, we could do project import subcatchments. And this will go back to the same two default files, and it will import this information back into our HydroCAD project. Now, nothing apparent is going to happen when we re-import. It has actually re-imported all of the area information, all of the TC data for this project. One way we could demonstrate that is that we could actually come in and we could remove a couple of subcatchments here. And then if I do a project import subcatchments, it will bring everything back in, including and recreate those two nodes. The routing we just need to reconnect here by hand, and now we're back to our original project. So it's a very powerful capability that allows all of that data to come in and out in tabular form. So that could be used for reporting, it could be used for tabular editing, it could be used for connecting perhaps to a GIS system where you might be extracting data and exporting that to a file. We also have matching import and export capabilities to allow you to export and import just the sub-areas, that is just the ground cover information, or just the flow segments, the TC data. The subcatchment option up top essentially does both of those together. So it automatically exports or imports both of those files. And the matching operations are available on the export menu. The next step, the next level, if you like, in importing and exporting data is to pre-configure this process so we can automatically move data in and out. And this can be done on this export or imports, actually the import settings screen is what I want. And you'll notice this has got a little tree here. This icon you will also find up here on Settings Watershed, and you'll find it over here on the toolbar on the far right. That's the most convenient place to look for it. So if we click the Watershed settings screen, we had a whole new screen with a lot of different capabilities. And the first thing you can do with this screen, even if you're not importing or exporting any data, is that you can use this to customize the specific ground covers that you want to use on a particular project. By default, when you edit your subcatchment, the entire lookup table of ground covers is offered to you. But on most projects, you are not using many of the options on that table. So what you might want to do is come in here to Watershed Settings, and we can come down and select None to deselect all those lines. And then we could select just the particular ground cover options that we want to use for this particular project. And so then when we click OK, if we come into a subcatchment and edit that subcatchment, now our lookup table is reduced, and it's showing us just the options that we've chosen to activate for that particular project. So this would allow you to set policy in a given project as to which ground covers you want to use, because obviously in most cases you're not using the dozens of different crop options that exist there. So this would allow you to remove those. Another thing you can do, which makes this easy to set up, there's a button down the bottom here to select the active ground covers. And that's a great capability. So when you have an existing project, you've already using a number of ground covers, we can click Select Active, and that goes through the project and selects just the ground covers that are actually being used within this particular project. And of course you can modify the selection from there. But now the user will be constrained to just using that set of ground covers within the project. This screen will get us into all sorts of other capabilities as well. In this case, we're just using it to select active ground covers. But if we go to the second tab for import settings, this is where we can configure automatic import of data into this project. And one of the first things we could do is we could configure the project for a tabular import. And we could use this to actually do the same import that we did a moment ago through the menus. We could specify that our sub-area data is to be imported from this particular CSV file, and then we could pick the file that our TC data is going to come from. And so these file settings will be stored within this project. We click OK. And now you'll notice on our routing diagram that we have these little red arrows that have appeared. And the red arrows indicate that automatic import has been configured for these particular nodes within the project. If we were to edit a subcatchment and come to the Area tab, it's now telling us that manual entry is not allowed because we've turned on the automatic import capability. So it's managing the import process here to protect us so that we don't manually enter a value that then gets overridden when we do the automatic import. We do have the option, of course, that we could uncheck this box and tell it that we don't want to do that automatic import for this particular subcatchment. The same options are available to us on the TC tab, whether we want to do that import or not. So now when I click OK on the subcatchment 4S, the arrow here has dimmed because it's not doing a full import. If we come back and edit that, the arrow's there because we still have automatic import configured for the project, but not for that particular node. So to do the automatic import, now we can just click a single button. So we can come over here to the toolbar, and this new button will give us quick access to the Watershed import, and we can do an import now, and this will automatically pull in Watershed data however it's been configured into this current project. Now, that's much the same as doing the project import that we did a moment ago, but we've pre-configured it for the project, and we can select specific files that the data is to be pulled from. But what gets more interesting about this screen is actually the other options here. The next one being to pull this data from CAD watershed layers. And this is what we'll get into in detail in a separate section, covering the AutoCAD import capability. And now we can define specific layers which will contain our different watershed information. So coming back to the ground cover screen, now we have additional columns that have appeared here. And these include columns which would specify the drawing layer on which each of these items will be drawn, and even patterns that will be used for hatching each of those layers. So a bunch of new options appear, and on import settings we can specify exactly how the ground cover information will be extracted from the project. And there's a whole bunch of different options here. So please do come back for that session in a couple of weeks, and we'll get into more detail on how that operates. So that's a quick overview of the data import and export. There's a lot there, but again, I'd urge you to drill into the help topics, which will give you more information. If you just go to Project, Import, Subcatchments, hover over that and click F1, it'll drill you into the help topic with more information on exactly how that operates. So this has been a quick overview of a lot of new features that have been added in HydroCAD-10. I would also point out that with HydroCAD-10, we do have new owner's manuals available. They're now being provided separately. Frankly, a lot of customers have asked just for downloads of the software, so the printed manuals and CDs are being sold separately if you're interested in those. But we do have a brand new HydroCAD-10 manual. It's now available for just $15 plus shipping and handling through the end of the year. So you can order that online. And please do have a look at our webinar catalog to see the future sessions that are coming up. And you'll also find a recording of this session that will be posted later today. So I hope you will join us for a future session when we'll get into more detail on each of these new topics. And thank you very much for joining us today, and we'll hope to see you then. Thank you. Have a great day.